Hello students, let's try to factor a quadratic when there is a missing x term, and hence how you can solve for x using difference of squares. So the topic today is difference of squares. So let's see what that means. Okay, so you are looking at this tool to solve for x when there is no missing term. If y equals ax squared plus bx plus c, then we are talking about a quadratic where there is no x term. So something like x squared minus 9, something like that, because we cannot have plus. We are not looking for sum of squares. We are looking at a scenario where you have difference of squares, so x squared and 9. So that's the goal. So let's talk about how to bring in that formula for difference of squares. So to know that, just try to multiply a plus b times a minus b. You can FOIL it or use a box method, whatever works. So you're trying to multiply a plus b times a minus b. So this is a squared, a times b is ab, negative b times a is negative ab, and negative b times positive b is negative b squared. So when you add, so a plus b times a minus b is a squared minus b squared. So let's look at the possibility. So we have a plus b times a minus b, they're being multiplied to get a squared minus b squared. So factoring is a reverse process of multiplication. We are going back this direction. So we are given a quadratic and we need to find the factors. So we are going in the reverse direction. So you will be given questions like this, x squared minus 9. So let's look at that. X squared minus 9. So this is exactly in the format of a squared minus b squared. The 9 is a perfect square, so it can be written as x squared minus 3 squared. So you're taking a as x and b as 3. So this could be factored out as x minus 3 times x plus 3. Okay, so if you take one more example, let's see, x squared minus 169. You need to know the perfect squares though. You need to know what's the square root of 169. Okay, so this is x squared minus 13 squared. So a is x, b is 13. So this comes down to x minus 13 times x plus 13. So now we'll talk about another example. Let's take 4x squared minus 9. When you have questions like these where the leading coefficient is not 1, it's something other than 1. So it is 4 here. But if you look closely, 4 is a perfect square and 9 is a perfect square, of course, and they're being subtracted. So we're finding difference of the squares again. So how can we interpret this? In the scratch, you can say 4 is 2 squared and this is x squared, of course. So we can actually combine them together as 2x whole squared minus 9, which is 3 squared. So now you consider a as 2x and b as 3. So now apply the formula. A squared minus b squared is a minus b times a plus b, right? So this comes down to 2x minus 3 times 2x plus 3. Okay, we'll do more. One more example. Let's take 25x squared minus 16. So this comes down to 5x squared minus 4 squared. So which is equal to 5x minus 4 times 5x plus 4. Okay. So sometimes you will also see questions like 9x squared minus 16y squared. Alright, so it's still the same process. Now both terms have perfect squares. So this is written as 3x squared minus 4y squared. So all of this will be equal to 3x minus 4y times 3x plus 4y. Okay, so you will see tons of examples. Now let's go to some other kind. Okay, so the next kind would be 2x squared minus 18. Is 2 a perfect square? Is 18 a perfect square? No. But there is a common factor in these two terms, which is 2. So you would